let me ask you about the snowflake work you did. Um, what tools did you use to load Snowflake natively and even with other tools? Give me the idea of, the whole pipeline, right? I mean,
Yeah.
raw zone or?
Yeah. So,
Okay, so I get that. So what did you do for the database change data?
Yeah, so there is another thing like CDC will be implemented on top of RDBMS. Hello guys, welcome back to my channel. So last week I gave one interview for Capgemini that was for Snowflake Data Engineer. It was L1 round, and I was asked a couple of questions which I am going to discuss here. And after discussion we have recording as well. If you want to hear that actual interview recording, so you can hear that as well. But before that, I will be discussing all the questions which he asked me. So the first question was like, what tools did you use natively to load the data into Snowflake? So there are various ways through which we can load the data into Snowflake. So I gave answer for SnowSQL copy command and SnowPipe and using PySpark application. But there are certain other ways as well which I am going to discuss here. First of all is like using like Snowflake web interface UI. So for quick and small manual uploads, the Snowflake web interface allows you to upload data files like CSV, JSON or any Parquet format files directly into a stage, which is a temporary storage area, and then use the copy command command to load the data into Snowflake tables. So this is best suitable for like small data sets and initial testing, or like when automation is not required. So in those scenarios, we will be using Snowflake web interface. Coming to SnowSQL CLI. So Snowflake's a command line client. It allows for executing SQL queries and performing data loading operations from local files or Snowflake stages. And this is like best suitable for automating data loads with scripts or integrating with other command line tools. Now we have a copy into command. So the core command in Snowflake for loading data, it supports loading from both internal stages, which is like Snowflake managed storage, and external stages like S3 or any Google Cloud Storage or Azure Blob Storage. So this is best suitable for like bulk loading data from files stored in cloud storage or Snowflake stages. Next we have SnowPipe. SnowPipe is the Snowflake's continuous data ingestion service, like that allows you to automate loading of data as soon as it arrives in a cloud storage location, which we call as an external stage. And this is best suitable for real-time or near real-time data loading needs. So handling any streaming data or when data files are generated and located frequently. Next we have external tables, where like external tables allows you to query data directly in files stored in external cloud storage without loading them into Snowflake. So while not a data loading tool, they enable querying data as if they were inside Snowflake, so which can be useful for exploratory analysis or like integrating external data sets. This is best suitable for ad hoc analysis of large data set in cloud storage without loading them into Snowflake. Now next we have a data sharing. So Snowflake's data sharing feature allows you to share data between like different Snowflake accounts without physically like moving data. So this can be used for loading data indirectly by accessing shared data sets. So this is like best suitable for collaborating with partners or like in between departments within an organization when direct data access is needed without duplication. Now we have partner ETL and data integration tools. So many third-party ETL tools are there, and data integration tools like have built-in support for loading data into Snowflake. Tools like Talend, Matillion, Informatica, Fivetran can simplify this process of like extracting data from various sources, transforming it and loading into Snowflake. This is best suitable for any complex data pipelines, integrating data from multiple sources, and when additional data transformation capabilities are needed. So these are basically the native tools which we can use to load the data into Snowflake. So let's go to the next question. So how did you implement CDC on Postgres? So this was the next question interviewer asked to me. So basically implementing like CDC, which is change data capture in Postgres or like in any database, involves capturing and tracking changes like insert, updates, deletion to the database, so that actions can be taken based on those changes, such as updating a data warehouse, triggering business processes, or synchronizing with other database. So there are multiple approaches and tools like you can use for CDC depending on the specific requirement of your project. So I had given the answer like what I have seen in my project. We had used Golden Gate with Oracle database. But since he asked me for the PostgreSQL, I'll be telling about how we can achieve CDC in Postgres. So we can have this logical replication which is native to PostgreSQL. This is a straightforward way to implement CDC. This is like by using its built-in logical replication feature which was introduced in PostgreSQL 10. So this logical replication involves using a publish and subscribe model where changes to a publisher database can be like replicated to subscriber database in real time. So for publisher and subscribers, we need to set up the tables like in your source database as publishers and configure the target system as subscribers that listen for the changes. Now we have another way that is called slot, like create a replication slot for a publisher. This slot keeps track of all changes to the publisher's data so that a subscriber can read the changes. And then we have the replication set. So we need to configure which table and operations like insert, update or delete should be replicated to the subscribers. Now we have CDC tools and platforms. So several third-party tools and platforms offer CDC capabilities, often with more features and like integrations than native database solution. So some of the popular options we can have like Apache NiFi, StreamSets, Talend. So we can use these third-party tools for CDC replication. Now coming to the third question. So the third question was asked to me, explain the data pipeline in your project. So in my project, we have various kinds of data pipeline which uses different stacks, but I chose this architecture to explain to the interviewer. So basically here I explained like we are having various data sources, and like we have data coming from RDBMS, RESTful APIs, we have like on-premise file system, any third-party services. Likewise, we can have multiple data sources, and basically we are ingesting data from data sources to S3 raw zone with the help of various ingestion mechanism. We in some cases, like we are using API gateway or CLI command. We can have any application developed through SDK. It can be SFTP. So there can be various mechanisms through which we can ingest data from data sources to S3 raw zone. Once the data present in S3 raw zone, the next thing will be like the data quality check. So the data cleansing, data validation, enrichment, all these things will be the part of data quality check, which will be done through a PySpark job. So all the information of each and every data set entering into data lake will be cataloged into a central repository, and basically we will make an API call to the central repository and fetch all the metadata information regarding that particular data set, and based on that response the data quality check will be performed. So once it cleans the data through PySpark job, the data lands to the S3 publish layer. So this is something like it. This is also a S3 location. We call it as a publish zone where clean data will be sitting. So once we have the clean data, the next thing will be the ELT job we have to run, where like we will be applying all the business transformation, adding audit columns. So those things will be taken care as part of our ELT job, and that will be also a PySpark, separate PySpark job, which will load the data into Snowflake target table, and Snowflake becomes the consumption layer. From here, like all the respective teams or any dashboard or any consumer will start consuming data from this layer, and this layer will have either Snowflake schema or star schema. Based on that, dimension tables and fact tables will be created. So again, that is a separate part of like data modeling and data warehousing. So how we are designing any data set for analytics. So that will cover all those things, and all these jobs will be like orchestrated in like Apache Airflow, and it will be like scheduled in Airflow. So this was my explanation to him. Again, as I said, like this is one of the example. You can choose any data pipeline, any architecture, any stack. So yeah, so this was the third question, and going to the next question. So then I was asked, how would you set up a Snowpipe, and how would you automate it? So setting up the Snowpipe in Snowflake for automating data loads like involves several steps, from creating a storage integration to defining the pipe itself. Snowpipe allows you to load data efficiently from cloud storage like Amazon S3, Google Cloud Storage, or Azure Blob Storage into Snowflake tables in near real time. So first of all, we need to create a storage integration first. In Snowflake, a storage integration object in Snowflake provides a secure way for Snowflake to access your S3 bucket without storing like AWS credentials in Snowflake. So this can be done by, you can run a command like create a storage integration, say S3 integration, and type will be external storage, storage provider as S3, and you can give the storage AWS role ARN and storage allowed location. So this will create your storage integration. So, and once this is created, next thing would be we need to create a file format. Again, that is optional. It's a one-time creation. If in your system, if it is already created, then no need to create it. And if your data files are in a specific format like CSV, JSON, Parquet, so you need to define a file format in Snowflake. So this is a very simple step. You can easily create a file format, like just create file format, give your format name, and type you need to provide type equal to CSV, and field optionally enclosed by quotes, skip header 1. So this is a simple example of like create file format. And once the file format is created, we need to create the external stage. So create an external stage that references your S3 bucket and the storage integration. So this stage is where like Snowpipe will look for file to load. So creating a stage is also super easy. Create stage, my stage. You need to provide the URL equal to your S3 path, and then storage integration we need to pass here, which we created earlier, S3 integration, and file format, which we created earlier, like any for CSV file format that we need to provide, and your stage will be created. Now next step is to create the Snowpipe. So define the Snowpipe object, specifying the source, stage, and the target table. This is also super easy. You can like use the statement like create pipe, my pipe, and you can set auto ingest as true, and then your copy command, copy into my target table from my stage, and you have to give the file format. Now next is like automate the data loading. So once the Snowpipe is created, with the help of auto ingest set to true, Snowpipe automatically starts loading data when new files are added to the stage S3 bucket. So to further automate and orchestrate this process, we can have event notification. So we can configure S3 bucket to send the event notification for new files to an SQS queue that Snowpipes listen to. So this setup triggers Snowpipe to load data as soon as like it arrives in S3. So, and then you have to monitor the Snowpipe. So for monitoring the Snowpipe performance and data load activities, you can simply run the command like select system $pipe status and then give your pipe name. So it will outline the process of it will show you all the status of your like pipeline execution. So this is how like we can set up the Snowpipe in an automated way through which data will be loaded. So yeah, and next let's go to the next question. So the next question came to me was what did you do with glue? So So this is my example again. In your case, it can be anything, any other example, but this was the example which I explained. So basically, we had a real-time data pipeline which was using like S3, Lambda, Glue, and Snowflake. The use case was like website activity tracking. So any like e-commerce transaction processing, or like anything happening in the real time to basically capture the website activity tracking. So this was the use case which I explained. Basically, this pipeline collects data on like user actions on a website, process the data in real time, and loads into Snowflake for analytics and insights. So this is a simple ask and approach for making we can say the serverless data pipeline. So all it starts from like data collection. So website activities like clicks or like page views are collected like using a JavaScript tracker embedded in the website, and collected data is sent to like Amazon S3 bucket, organized like in the raw format. Then we have Lambda function. So set up a Lambda function triggered by S3 event notification. Basically, that will be a put events when new activity data files are uploaded to the S3 bucket. So each Lambda function like processes the raw data in real time. This could involve like a data cleansing, transformation, and enrichment. And then next we will be having data transformation with AWS Glue. So for more complex transformation that cannot be efficiently handled within Lambda's execution time limits, so we will be having Glue, which will be triggered from the Lambda function. And in the Glue, we will be using like Glue crawlers to infer schema and create metadata tables in the AWS Glue data catalog. Once that is done, we have to load the data into Snowflake, like from S3 to Snowflake. After processing and transformation, the data is ready to be like loaded into Snowflake. So we can use the Snowflake copy command to load data from S3, and we can automate the loading process by setting up like Lambda function that executes the copy command into Snowflake through Snowflake JDBC driver or Snowflake connector for Python. Next thing is like the real-time analytics and reporting. So we were utilizing the Snowflake's like powerful data processing capabilities to perform like real-time analytics on the processed website activity data. And we can connect any BI tools to Snowflake to create dashboards and reports that provide insights to the user behavior. In our case, it was Tableau dashboard. So Tableau was used for making all the insights and dashboard. So this was the simple example of the Glue serverless pipeline, which I explained. And then going to the next question. How did you perform like data validation and cleansing? Did you use any package? So data validation and cleansing like in Snowflake like involve checking the accuracy and the quality of your data before like it is used for analysis, reporting, or further processing. So Snowflake SQL capabilities allow you to perform a variety of data validation and cleansing operation directly on your data within Snowflake. But in my case, all these data validation and data quality check cleansing thing we were doing at the very initial level as soon as the data lands on the raw zone, right? So at that point of time, we will be doing all these validation. But interviewer was expecting me to perform all these validations at a Snowflake layer. I told him like this is possible, but in our system we are doing all this validation much before data comes to the Snowflake. So we are doing the ETL load on the clean data. So and that is being loaded to a Snowflake. But still, like if we have to perform like such kind of data validation at Snowflake layer as well, definitely we can do that. For example, like we can identify incorrect or malformed data. So suppose you have a like customer table like with columns ID, name, email and phone number, and you want to validate the email address and like clean the phone number data. So for validation of the email address, you can check for the presence of @ symbol and the domain name. So those things like we can have in our like validation SQL. So and if you want to identify phone numbers that need cleansing, so again with the help of like regex pattern, you can find out like which phone number is not coming as expected, and then we can apply some cleansing mechanism. But again, this is possible at Snowflake layer, but that's not required. If you are addressing this much before, as soon as data lands on on S3 raw zone, if you are performing all these things there itself, then no need to take care of doing again. That will be a redundant work basically, I would say. So this was my answer. Coming to the next question. Explain Snowpipe like bottleneck situation and how did you overcome? So I have never seen any bottleneck situation using Snowpipe, but there may be scenarios like we can have bottlenecks in Snowpipe. One is like high frequency of small files. So Snowpipe processes each file as a separate load once it's available in the staging area. So if data is arriving at a high frequency of small files, the overhead of initiating and managing loads for each file can impact the performance and increase cost. This is one thing. And in case of getting very large files, like while Snowpipe can handle large file, loading very large files might take longer time to process, which could like delay the availability of data for querying. This is possible, but I haven't seen like in real time till now. And also like API rate limits, also it can impact your performance. Like Snowpipe relies on the external cloud services like S3 for triggering events, right? So if you are using external functions to trigger Snowpipe loads, like you might hit API rate limits. So these are like few scenarios where we can have bottlenecks using Snowpipe. There are strategies to overcome these bottlenecks, like batch small files, like pre-processing You have to pre-process the few things, like implement a pre-processing step to a batch multiple small files into larger one before they are loaded into the staging area. So we can use tools like AWS Lambda, which can automate this process by periodically aggregating files in S3. We need to split large files for very large files, considering splitting them into smaller, more manageable sizes. This can be done before the files are uploaded to the staging area. So ensuring that each piece can be processed quickly and efficiently. And we need to optimize the file size. So follow Snowflake's recommendations for file size, typically between 10 MB and 100 MB after compression, so that we can achieve an optimal balance between file handling, overhead, and processing efficiency. We can leverage streams and tasks for managing continuous data loads more efficiently. Consider using Snowflake streams on the stage files. This can help identify new or changed data since the last load operation. Snowflake task, you can automate the loading process with Snowflake tasks, which can be scheduled to load data at optimal intervals, reducing the need for immediate processing of every small file as it arrives. So these are few strategies through which we can overcome the snow pipe bottleneck. Moving forward on to the next question. Have you used Snowpark? So I told him we have used Snowpark as part of POC, but we are not in production with Snowpark. So the POC, basically it was a customer segmentation analysis. Basically we wanted to perform customer segmentation analysis on a e-commerce platform, user data, to identify distinct groups based on purchasing behavior, preferences, and demographics. So basically that analysis aimed to enable personalized marketing strategies and improve customer service. So for that we had used Snowpark, and as part of the data pipeline we have various steps ranging from the setup and the data preparation. So assume that you have access to customer data in Snowflake, and for example, we can take tables like customers, orders, and products, and then we have to set up the Snowflake environment with the Snowpark library dependencies for your Python. So this might involve configuring a virtual environment and installing Snowpark Python with a pip install. So that is required. And next, as usual, we have our data exploration and cleaning step. So we can use a Snowpark to load and explore your data. So, and once that is done, we can perform cleaning activity such as handling missing values, outliers, or using Snowpark. We can basically we will be creating data frames operation, and we can perform all these activities. Next step was feature engineering, where we created the new feature that might be relevant to segmentation, such as total order value, average order size, product categories, purchase, frequencies of purchases. So these kinds of features we had to create, and then there was a customer segmentation model. So I was not the part of the creating that model, but my other team members, they had used the clustering model for segmentation, which was k-means, and then the model was trained, and after that analysis was done. Once the model is created and trained, we can analyze the characteristics of each customer segment. So this was the small POC was done in the Snowpark. So yeah. And coming to the next question, did you use a stream task on external table to capture change data? If yes, how? So I explained him I have used not directly on the external table, but so we have used with the Snowflake managed table, we have used the streams and task. So, but using Snowflake's stream and task on external table, I would say it would be a sophisticated approach, to implement the CDC for data stored in external storage, such as Azure Blob or S3 or some other location. Snowflake allows you to define external tables that reference data in these cloud storage, enabling you to query this data directly without having it load into Snowflake. So when combined with streams and tasks, this setup can efficiently process and capture changes in near real time. But we cannot use Snowflake streams do not directly support external tables as per my understanding. Instead, you would typically ingest data into Snowflake managed table to leverage streams. So this is as per my understanding. We cannot have streams on external table. So yeah, so that is what I told him. So let's go to the next question. Have you used copy validation mode in Snowflake to perform data validation? Now, I'm not sure about, he was very confident and he was explaining me, you will come to know in the, when you listen the interview audio. So you will come to know he was, what he was asking about the copy validation mode, but I did not have an answer for this. And I'm not sure in Snowflake, do we have any copy validation mode or something like that? If you guys know, do let me know. You can comment for this question. It would be helpful for me as well. So let's go to the interview recording now, where you can listen the recording of my interview with Capgemini.
So let me ask you about the Snowflake work you did. Mm-hmm. What tools did you use to load Snowflake natively and even with other tools?
So we load data into Snowflake through PySpark applications. We have Snowpipe data pipeline for loading data into Snowflake, and occasionally we use SnowSQL and copy command as well, but mostly with SnowPipe and PySpark.
Okay, so did you write any of the PySpark code
Yes.
for loading? Okay, and so kind of give me the idea of the whole pipeline, right? I mean,
Yeah. So basically,
sources,
yeah, sure.
Final stages.
Yeah, so we have basically various kinds of data pipelines, and data is coming from like various sources. For example, like various data comes from our databases, RDBMS like MySQL, Postgres. We do receive data from APIs, any RESTful services are there, or any streaming APIs. So we get data from those APIs as well. Any on-premise file system, we have any other cloud storage, we get data from there as well. And we do get data related to application logs or any clickstream data. So these are the various sources through which we are getting data. Now, so first of all, our data lake is on top of S3. We have made our data lake on S3, and there is a raw region in the S3 data lake. Any data which is getting ingested from source to will come to S3 raw zone basically. And for data ingestion from source to S3, we are using like various types of mechanism. Sometimes it will be normal SFTP transfer. Sometimes we will be creating some SDKs. With the help of SDKs, we will make some application which will pull data from source to S3 raw zone. And sometimes why we use AWS existing like component for pulling the data, like data sync, if any large volume of data if we have to bring to S3. So data sync we will be using, or recently we have used DMS as well. We had few RDBMS transactional databases which was in RDBMS. So we migrated those database to AWS cloud using DMS. So these are the various mechanism through which the data will be ingested to the S3 raw zone. So after,
you put everything in the raw zone, or
yeah. So
okay, so I get that. So what did you do for the database change data?
Yeah, so there is another thing like CDC will be implemented on top of RDBMS. So that will capture only any DML operation is happening on the database. So those things will be captured and it will be streamed to our S3 raw zone. So
yeah, but what tool or did you do any of that, or it just was there and you worked from changes and then how? Yeah, okay, go ahead. I'm sorry.
Yeah, so there is in Oracle database, there's the Golden Gate gateway mechanism through which the CDC will be captured. So that configuration has to be done with the database. And once,
yeah.
So once,
how about Postgres?
I'm sorry.
How about Postgres?
In Postgres, how CDC will be implemented, you are asking?
Yeah, how did you do it? I mean, you didn't personally have to do it. Do you remember how they did it? Or?
So see, yeah. So for CDC in Postgres also, like we have to do the similar kind of thing. And so basically, I'm not involved in.
Did you use Golden Gate? Okay. Okay, but okay. So Oracle, they use Golden Gate. Yeah, that's I don't know if they used it for Postgres. It would probably be usable, I would think. Don't know. I've used Postgres for many databases, right? So Yeah. Okay. So now everything's in the raw zone. Now, what happened?
So once data lands to raw zone, then we have to there will be certain data quality checks. So before any data set entering into data lake, we have to catalog each and every data set entering data lake. So basically, we will be having some central repository for cataloging, and all the metadata information will be stored in that catalog. So ranging from like what is that data set description, all the column names and data types, range, values, who is the data steward, data owner, in data lake where this data set will be sitting, like the location of the data set in data lake. Those things will be like registered in the catalog. And once the data set lands to S3 raw zone, first of all, we will be applying data quality check. And as part of data quality check, we will be checking all the data types, the nullable, not nullable things we will be checking. Those things will be checked, and if any enrichment is required, so those things will be done. And
what kind of file format did you have in S3?
So we receive like various file formats, especially like it can be like CSV, JSON, or even we are receiving Avro and Parquet as well. But when we process the data further, we will be always like using Parquet and Avro in the most of times when clean data moves in the forward direction. So it will be processed in Parquet format only. But usually the incoming data to raw zone will be mostly in JSON, or if it is a streaming data, it will be in the JSON or Avro format. Sometimes CSV also comes. Yeah.
So now you want to build a layer, right? That's going to move this into Snowflake. You're saying you use Snowpipe as one,
yeah,
mechanism, right? So for the Snowpipes, how did you set that up?
So
hang on.
Yeah.
Go. Hang on. I've got somebody pinging me.
Okay.
Okay, that should take care of them. Okay, yeah. So yeah, you got How did you guys handle this?
So in this pipeline, say we got the data in S3 raw zone, and we have applied data quality checks, and we made data as a clean data after enrichment, and the clean data is again landing to S3 publish layer. So now I am assuming we have data sitting at published layer, clean data. Now we have to build a pipeline using Snowpipe that will be loading data to Snowflake. So for that, we need to basically create a stage in the stage over the S3 location. So we have to create that stage in the Snowflake, like we can do by like create a stage, say S3 stage, and we can pass the URL of S3 location, and along with the credentials, basically we need to pass your all AWS access key and secret key thing we need to pass while creating the stage. Once the stage is created, we will be creating our tables, for example any sale table if we are creating, and then we need to create the Snowpipe to load the data from stage to the target table. So for that, like we can run the create pipe command.
Yeah, those are, but how are you handling, say, the automation of the pipe?
So again, this will be handling automation will be done through Lambda function. So this Lambda function will like trigger the Snowpipe, and the Lambda function will be like event based, or it can be orchestrated through Airflow. So depends on like how we are building the pipeline. So if we want to make it event based, then there will be like it will be Lambda function will be connected to the S3 event. So any clean data landing to the published layer, so the Lambda function will get triggered and it will trigger the Snowpipe.
So did you write the Lambda?
Yes, I have written Lambda functions as well. And
did you write it for the Snowpipe? How did you check the status of the queue for?
Check the status of the queue as in
usually your Lambda have to pick up the event.
Yeah.
To call the pipe.
So we generally check the CloudWatch logs.
Okay. In Snowflake, right? I mean for AWS, you're right. For S3, you'll have logs. You're checking logs, and you haven't set up queues. No SNS queues or SQS.
Those things are also there. Yes, definitely.
See, so the Lambda doesn't pick an event out of the queue. So
again, how if you want to build a pipeline using Lambda and
no,
SLS?
I mean, you showed me how you build the pipeline.
Mm-hmm.
Now you're talking about how do I trigger the pipeline?
Yeah, so that's what I told. Yeah. We were using like S3 as the event source. That is like one way to build the pipeline and automate it. One way is you can use SNS or SQS as well for event notification or for queuing purpose, as you mentioned. So depends.
Yeah, those are the ones I use. So I'm very curious how you did it without the queuing functions that are built into S3. You did it with like logs or something. So you build a Lambda function,
mm-hmm.
and it wants to find a new event. What's the source of the event?
S3 event. S3 as an event source.
Well, yeah, it does. But, to me, those events are in SQS or SNS. They're in the queue, but I don't know how else it provides it. I mean, maybe there's an automatic connection between, a Lambda you run and some other source. But if I understand it right, my understanding, what I built was, I forget whether it was SQS or SNS. I had my choice, right? But
yeah.
I set up a monitor of that as my event source.
Right, you're right. So if we are setting like SNS or SQS, so the Lambda function is subscribed to SNS topic receiving any S3 event notification in that case.
Okay.
Yeah.
Okay, so you could do that. The
yes.
Lambda can be subscribed.
Yes.
Okay.
Yes.
Okay, didn't know that. You did Glue, you're saying. What did you do with Glue?
So, okay, we are doing like data pipeline enhancement also. Like our usual, the legacy pipeline was using basically Spark for most of the heavy lifting and the ETL part. But later on, like the requirement came to build the serverless data pipeline. So we started working on like AWS Glue, and then like we figured out the various other things which makes it as a complete serverless data pipeline. And so there were various advantages we were getting as part of enhancement by using Glue. So in some of the data pipeline, we are using Glue as well. Which makes it a completely serverless data pipeline, and the cataloging is done automatically, and it's a whole package. Basically, you can create the workflow, you can schedule it, and everything is like included in the Glue. So you need not have to. Everything is like AWS managed, so you can build the whole serverless pipeline using AWS Glue, and some of the good feature regarding when we are making the dynamic data frames. So we are also like getting some extra features like as compared to the Spark. So
With PySpark, yeah, you
Yes,
have
PySpark.
some advantages with it. Let me just ask you quickly, when you do the reconciliation to taking from your raw layer to your published layer, where's all, how are you writing all of this data validation and cleansing? What are you doing to do that?
So it will be basically done in Spark. So we have the data quality check and cleansing things written in the Spark job. So Spark job will be triggered and it will do all the cleansing process. And it will check the.
You're saying it checked all the data types. Like where's all this information stored?
Yeah, so those information, as I mentioned, those informations are cataloged whenever we are registering any data set into the central repository. So those information will be stored there, and it will be called through an API call whenever we want to do some quality checks, like the data type and any range values. Those things, if you want to check by making an API call to the central repository, we fetch that information, and based on that, we do the data quality check. And any missing values or any null values, those things will be checked and duplicate.
Did you use a package to do this, or?
Mostly, if we are with PySpark, we have our own methods we have written for each data quality check. So basically, those are adapters, and which adapter we want to use. So that thing we are using.
Okay. So we've gone to published layer.
Yeah.
You say, okay, some of it goes, or maybe I don't know how much of it goes Snowpipe, but there are obviously limitations with Snowpipe, right? And how did you guys know, to say, hey, these buckets with files are too big, right? Or they're too small, something like that, to be able to say, how do I know which I can't use Snowpipe for and I need another methodology?
So, so basically, usually Snowpipe and copy command use large data. But even though if we have a very huge data processing we have to do, then Spark is already there. And before that, like processing very large data into like Snowflake, we have to like build the pipeline smartly. Say like we have to organize the data in S3 first. Basically partition the data before loading, and organize the data into partitions in S3. So this could like be based on timestamp. We can partition the data.
Partitioned. Okay. Yeah. Did that guarantee it would work with Snowpipe, or?
So these methods like will help you moving large amount of data like from S3 to Snowflake.
Well, yeah, if you're partitioned and then the pipe is running on each partition, maybe the partition is under the 150 megabyte limit or recommended limit, right? Doesn't mean it won't do it, right? And you're saying, well, I always had the PySpark to fall back on, right?
Mm-hmm.
Yeah. Did you ever use Snowpark to do anything?
As part of like POCs, we have used Snowpark, but not in the real production. So again, that is again the part of like pipeline enhancement. We also started using streams and tasks as part of pipeline enhancement, and we are like seeing where we can implement those things, which can save our time and the pipeline cost. So those things we always try from time to time. But Snowpark is not in production as of now, but already done some POCs on that.
Okay. So for streams, right? it sounds like you've already done your change data, right?
Mhm.
But because you've moved, well, if it was all in the data lake, right, you moved the change, right? And I don't know if you're putting external table or you knew what file to use your copy command for, right?
External table again. We have used external table as well. Basically, it allows the Snowflake to query the data that resides outside the Snowflake managed storage. Basically, typically in a cloud storage, it can be anywhere like in S3 or any like Google Cloud Storage or Azure's blob storage. Like without ingesting into Snowflake
Sure,
storage.
but
Yeah.
I mean, you could have put a stream over the external table to pick up your change data as well, right?
As part of POC, yeah, I think we can do that. But as part of POC, we haven't done that. We took the table from Snowflake itself, from the managed storage, and then like we created the stream.
Stream on top of a managed
basically,
internal. Okay,
yeah.
that's fair. I mean, you can actually do it on an external
we
as
can
well.
do it.
But
We can do it.
yeah. Okay, so now everything's, say, in an internal landed layer or published into S3. What about the rest of the transformation steps in the pipeline? What?
So all the heavy lifting transformations will be either done in like PySpark job or any. We have used DBT as well for transformations for building the ELT basically pipeline. So yeah, and in Glue also we can do that.
Now, is that Python? I mean, PySpark, Python's essentially executing SQL?
Yeah, with the help of Spark SQL, creating the data.
I mean, you're going to make your data frame and then transform and
absolutely
then do your movements. Okay.
Mm-hmm.
So is any of it reusable, or is it kind of each schema has to be
I
dealt with?
I didn't get the question. What is
well, okay. Were you able to leverage, one piece of code to work with multiple, right? Like it, is it able to essentially create a data frame and then bring back the dictionary and then use that? Or is it each job for each table when you, transform it and move it? If it's not reusable, that's okay. I'm just curious, right? I'm seeing if you guys tried to implement some type of, generic template to do it.
Basically, when you say the generic template, so we are generalizing the transformation logic basically. Just by
the transfer, you kind of got to declare it when you transform it, right? So that would be, that wouldn't really be usable because for data movement, you could implement something generic, I think, right? But like Parquet, I'll give you an example, right? There's always, if you had a Parquet file in S3, right, you can always infer the schema and use that schema, right? It can be picked up automatically. Right? And from a data frame, right, I could always create the schema. But your transform's your transform, so it would have to understand what you're doing. So it's absolutely right. Were you guys able to utilize anything reusable, or it's kind of just each, data set is treated right that way?
Definitely, reusable components will be there. So we have to build those reusable components. For example, if you want to do some data quality checks, right? So for data quality check, we will create a reusable adapter, and that reusable adapter will be used for each and every data set for the for the data quality checks. So likewise, reusable components definitely are there as part of data pipeline development.
Okay, hang on. Somebody's pinging me. One
Okay.
minute. Okay, I'm good. So I'm about had one more question. Let me think of it. It just escaped my mind here. So yeah, we're saying we're building PySpark, and you use dbt to do it, right?
Right.
Right. Okay. I worked with any other ETL tools?
I have worked with Glue, AWS Glue.
Glue and dbt, right?
Glue,
But if
dbt,
they
and
have
PySpark, yeah.
Okay. So, and that might be all this client is using, right?
Mm-hmm.
I mean, you could clearly write your. Yeah. I think that it's a good fit because what this client does want to do is use a lot of data frame, a lot of Python with data frame for movement, transformation, validation, if they've thought of that. Do you know another way to do validation without writing your own framework in Snowflake?
Data validation in Snowflake?
Yeah, there's a specific. So it's just a right one of those interview questions.
Can you write like little brief on that? Like what kind of validation?
I'm going to do a copy, but I want to check everything, right? I wanted to check all the data lengths, everything you did with data quality, right? Data type, data lengths, enclosing characters, things like that. And then I want to be able, right, to see what rows don't pass. And I can do this in Snowflake without having to write an entire framework.
So,
copy validation mode. You can use validation mode with copy, and you can create a whole. It'll do all the same thing.
Because in our data pipeline, see, data quality check has to. This is the consumption layer. Snowflake is a data warehouse. So
right. I mean, we set up a separate layer in Snowflake to do it, whereas you've done it in the S3 layer. So.
Yeah. We can do it in Snowflake as well, but in our pipeline,
No, and you could have run your Spark and all that. It just seems like okay, you guys put work into your own framework, right? But Snowflake has a native framework to do this kind of thing. So it's okay. You get bonus points for writing all the code for the framework. That's fine, right? I'm not saying you should have done it that way, right? You know. Okay. Hang on for 1 minute.
Sure.
Yeah. Okay. So we'll arrange a second interview, right?
Okay.
And I don't know. I'm going to have to fill out a whole bunch of paperwork and do that. Usually there's people available. So I don't know when they'll get back to you, but it should happen.
Okay, no problem.
I would think before next week. Okay?
Sure. Yeah.
Yeah.